Hey guys, welcome to another episode of Learn with Sir Glenn, and for this video, we're going to discuss power theorem. So, let's go! Power theorem. The power theorems are theorems on the proportionality of segments formed by intersecting chords, seconds, and secant and tangent. So for this lesson, we're going to discuss three power theorems. So the first one is a chord-chord power theorem, which is formed by intersecting chords. Then we have the secant-secant power theorem, which is formed by intersecting seconds outside the circle. Then the last one is the secant-tangent power theorem, which is formed by a secant and tangent intersecting outside the circle. Okay, so let's have the first theorem, chord-chord power theorem, or also known as two-chord power theorem. According to this theorem, if two chords intersect inside a circle, then the product of the lengths of chord segments are equal. So let's have a circle, and let's have chord AB and chord CD intersecting inside the circle at point E. So when two chords intersect inside the circle, each chord is divided into two smaller segments. These segments are called chord segments. So let's have chord AB. On our chord AB, it is divided into smaller segments which are segment AE and segment BE. So therefore, we have segment AE and segment BE are the chord segments of chord AB. Then chord CD is divided into smaller segments which are segment CE and segment DE. Then we have segment CE and segment DE are the chord segments of chord CD. So according to the theorem, so the product of the lengths of the chord segments are equal. So therefore, we will have measure of segment AE times measure of segment BE, which are the chord segments of chord AB, is equal to measure of segment CE times measure of segment DE, which are the chord segments of chord CD. So how to use the theorem? So for example, we have these measurements. So BE is equal to 2, AE is equal to 6, CE is equal to 3, then we're going to solve for DE. All we have to do is to replace our segments with the given values in our figure. So therefore, we will have 6 times 2 equals 3 times DE, replacing AE with 6, BE with 2, CE with 3, and since we're solving for DE, we're going to leave DE as is. Then solving for this, 6 times 2 will give you 12, which is equal to 3 DE. Divide both sides by 3, then we will have DE is equal to 4. Okay, so let's have our next power theorem, secant-secant power theorem, or also known as 2 seconds power theorem. According to this theorem, if 2 seconds intersect in the exterior of the circle, then the product of the measure of one secant segment and its external secant segment is equal to the product of the measures of the other secant segment and its external secant segment. So let's have a circle, and let's have secant AB and secant AD intersecting outside the circle at point A. So when 2 seconds intersect outside the circle, we will form a secant segment, which is a segment of a secant line that has exactly one point on the circle. On our figure, an example of secant segment is segment AB. Then if you have a secant segment, you will have a secant segment that lies in the exterior of the circle, and this is called the external secant segment. On our secant segment AB, segment AE is our external secant segment. So therefore, we can say that AB is the secant segment and segment AE is the external secant segment of secant AB. Then on our other secant, we have segment AD as our secant segment, and segment AC is our external secant segment of AD. So we have AD is the secant segment and AC is the external secant segment of AD. According to our power theorem, the product of secant segment and the external secant segment is equal to the product of the other secant segment and external secant segment. So therefore, in our figure, we will have the measure of segment AB times the measure of segment AE is equal to the measure of segment AD times the measure of segment AC. So AB is the secant segment, A is the external secant segment, AD is the secant segment, then AC is the external segment of AD. So how to use the theorem? So let's say we have AB is equal to 12, AE is equal to 2, AC is equal to 3, then we're going to solve for AD using our secant-secant power theorem. So all we have to do is to substitute the given measurement on our equation. So therefore, we will have 12 times 2, replacing AB with 12 and AE with 2, is equal to AD, since we are looking for AD, times 3, replacing AC. So solving for this, we will have 24 is equal to 3AD, divide both sides by 3, then AD is equal to 8. Okay, so let's have the last power theorem, the secant-tangent power theorem. According to this theorem, if a tangent and a secant intersect in the exterior of a circle, then the square of the measure of the tangent segment is equal to the product of the measures of the secant segment and its external secant segment. So let's have a circle. Then let's have segment AB as our secant. Then segment AC as our tangent segment. A tangent segment is both the external and the whole segment because it is the segment of the tangent with one endpoint on the circle. So in our figure, we already know that AB is our secant segment and AE is external secant segment. So therefore, we can say that AB is the secant segment and AE is the external secant segment of secant AB. Then we have AC is our tangent segment. So AC is the tangent segment. So according to the theorem, the square of tangent segment is equal to the product of secant segment and external secant segment. So therefore, in our figure, we will have AC squared, which is our tangent segment, is equal to AB times AE, which is the secant segment and the external secant segment. How to use the secant-tangent power theorem? So let's say we are given that AB is equal to 9 and AE is equal to 4, then we're going to solve for AC. So all you have to do is to use these measurements to replace the segments on our equation. And this one will give us AC squared is equal to 9, replacing AB with 9, times 4, replacing AE with 4. And solving for this, we will have AC squared is equal to 36. So get the square root of both sides, then you will have AC is equal to 6. Okay, so we're done now with the 3 power theorems. So now we're going to use those 3 power theorems to solve for the missing segment. And for the ease of solving, you can just simply follow these steps. So step 1, power theorem, is to determine the power theorem that applicable to the given. And step 2 is equation. So make an equation using the power theorem. Step 3, substitution. We're going to substitute the given measure to our equation. Step 4, solution. So solve for the missing using algebraic operations. Then step 5, answer, or you will have your final answer. So now let's try to use these steps to solve for the missing segment. So let's have the given figure. Let's say that CE is equal to 12, BE is equal to 4, AE is equal to 6, then we're going to solve for DE. So, solve for DE. So, step 1 is to identify the power theorem which is applicable to our given. Since our given has 2 chords intersecting inside the circle, then we will have chord-chord power theorem. And according to the chord-chord power theorem, the product of the lengths of chord segments are equal. Therefore, in our equation, we're going to multiply the chord segments on our figure. We will have AE times DE, which are the chord segments of chord AD, is equal to BE times CE, which are the chord segments of chord BC. So after this, we're going to have substitution. We're going to substitute the given values to our equation. So since AE is 6, we're going to replace AE with 6. Since we're looking for DE, we're going to leave DE as DE. Then BE is 4, then CE is equal to 12. So our equation will become 6 times DE is equal to 4 times 12, replacing AE with 6, BE with 4, CE with 12. Then solving for this, we're just going to apply the multiplication. That will give us 6DE is equal to 48. We divide both sides by 6, then DE is equal to 8. So therefore, the measure of segment DE is equal to 8 units. So since we are talking about lengths of your segment, we can just simply use the word unit if there's no given unit of measures on our measures. Okay, so let's have another example. So let's say AC is equal to 25 and AB is equal to 10. So solve for AD. So again, the first thing we're going to do is identify the power theorem which is applicable to our given. And for this one, it is composed of a tangent and a secant, so therefore, secant-tangent power theorem. And according to the secant-tangent power theorem, the square of tangent segment is equal to the product of the measure of the secant segment and its external secant segment. So since our tangent segment is AB, so we will have AB squared is equal to the product of secant segment AC times external secant segment AD. So our equation will become AB squared, the tangent segment, is equal to AC, the secant segment, times AD, the external secant segment. Then after this, we're going to have substitution. We're going to substitute the given measures to our equation. So we will have 10 squared, replacing AB with 10, is equal to 25 times AD, replacing AC with 25. Then we will have, solving for this, 100 is equal to 25 AD. Dividing both sides by 25, you will have AD is equal to 4. So therefore, the measure of AD is equal to 4 units. Now let's have our last example. So let's say on our figure, we have AC is equal to 15 centimeters, AD is equal to 6 centimeters, and AB is equal to 18 centimeters. Then we're going to solve for AE. So solve for AE, or solve for the measure of segment AE. So first step is to identify the power theorem which is applicable to our given. Since the given is composed of two seconds intersecting outside the circle, then this is secant-secant power theorem. So according to this theorem, the product of the measure of one secant segment and its external segment is equal to the product of the measure of the other secant segment and its external secant segment. So therefore, our equation will become AC times AD. This is from the secant segment AC, and its external secant segment AD is equal to AB times AE from secant segment AB and external segment AE. So after this, we're going to substitute the given measurements on our equation. So we will have 15 times 6 is equal to 18 times AE. Then solving for this, we're just going to multiply 15 times 6. That will give us 90 is equal to 18 AE. Then we divide both sides by 18. Then we will have A is equal to 5. So therefore, the measure of segment AE is equal to 5 centimeters. Okay, that's it. Thank you for watching and hope you have learned something from this video.